All right, so for problem number 7 here, now we're going to go to our graphing calculator, and we are going to do the quadratic regression. Now this is just like what we did in, I believe it was 1.3, when we did linear regression. We enter the points in the same way, except it is going to be quadratic, which is a different one on the menu. Instead of linear regression, we push quad regression. The only difference here that this problem doesn't ask for is I'm going to have you, once you plot your points in, I want you to try something in your calculator, okay? All right, so to do this, to enter these points, and these are the same as the ones up here. These are just, this picture up at the top is when I entered them in the calculator, what it should look like. But here's our table that we're going to use to enter in. So we're going to push the stat button, which is right here. I'm coloring it in, okay? And then it gives you a menu, or along the top it says edit, calc, and then something else. But we want the edit under the very first menu, so push number 1. Under L1 is where we put those X values, so these X values. Push enter after each one. And then under L2 are the Y values, and push enter after each one. All right, so once your data looks like this, so pause, and then once your data looks like this, then push play again so you know what to do. All right, I want you to go to your stat plot. I want you to turn it on. So I want you to push the second button and then the Y equals button, okay? Above it in blue, it should say stat plot. And I want you to, whoops, if I push it right, on number 1, so push the 1 after that, so it goes to that first one, and where it has the words on and off, I want you to push enter and select, or I want you to get your scroller over the on and push enter, okay? Then I want you to push the Y equals again, and make sure all of your equations are blank. If they're blank, then push graph. Okay, this is going to allow you to see those points. Now, when you push graph, your points probably do not show up because they're bigger than what's on your screen. Your screen is usually goes to the left -10, to the right -10, down -10, and up -10. And that's by setting your window. But to zoom out, if you push that middle button along right under the screen, the middle one says zoom, click on that. Number 3 says zoom out, and then you have to push enter. And then keep pushing enter until you see points plotted on that graph. And it should look like, you should see some points like if this is my, oops, I'm not drawing. If this is my X coordinate here, you should see some points that are kind of like, I don't know, something like that. See how it's curved? That's telling you that it's going to be a quadratic, okay? Because there is a problem in the practice that wants you to determine quadratic or not, and it's always a good way to just check it. Even though I showed you how to do the differences in the last video, there's multiple ways to determine if this is better as a quadratic or better as linear. So go to your calculator and push second and then Y and turn your stat plot back off, because it'll throw some things off if you're trying to graph things later. So you need to know that's how you get those points to plot, is using that stat plot, because we entered those points under stat, okay? All right, so you check that. You see how it's a curve. All right, let's go back. You have those points under stat. So now you're going to go to the stat button again, which is this button right here. Then you scroll over to calc. Okay, because remember the menus are edit, calc, and test. So scroll over to calc, and we want quadratic regression. Now for me, that's number 5. Okay, but make sure it says this, quadratic regression. And then you push enter until it gives you this information. Okay, if it doesn't give you R squared, then you need to turn, your diagnostic on under your catalog is not on, but for quadratics we don't need it. We needed that for linear, okay? All right, but this gives you A, it gives you B, and it gives you C that you plug into your standard form, which we found A, B, and C when we used 3 points to find our quadratic equation. But with given a lot of data, a lot of times, like there's some outliers, like maybe there could have been a point like here or here, okay? The ones in the tables before, it worked out perfectly, okay? This is what we use. If it doesn't work out perfect, this is the closest quadratic or closest parabola to all the points. So if we want to write our equation now, in number 7, it says, use the quadratic feature to find a function that models the data. So that is y equals, and it's a, and our calculator should tell us a is that. So negative 0.015 times x squared plus b, and b is right there, all right? So I'm going to say plus 1.554, because that 3 rounds up, x, plus c, which I'm running into my picture here, and c is a negative, so I'm actually, instead of plus, I'm going to put minus 10.863. Now, big ideas might just want 2 decimal places, so this would have been 0.02 x squared plus 1.55x minus 10.86, okay? I'm not sure which way they want their answer. But now I want you to go back to the problems that we didn't finish. So because the problems in the practice that use linear regression, it then wants you to take that quadratic equation and use it to find other information. So up here, we used our quadratic equation to find this. On this problem, it helped us find after 6.5 seconds. So let's go back. Actually, number 3 is one of them, but let's go back to the front on number 1. Okay, so we had found this equation for y is the height in feet and x is the horizontal distance traveled for a human cannon. If a person is shot out of a cannon, sorry. So the performer lands in a net 60 feet from the cannon. What is the height of the net to the nearest foot? So if this is our equation, it wants to know when x is 60, okay? Because if you look at the picture, distance was the x value. It's the horizontal, okay? So y is going to equal negative 2 over 125 times 60 minus 25 squared plus 30. Now, you can type that in exactly like that into your calculator, or you can actually, the equation you originally found, okay, this equation up here, if you were to plug that into your y equals and you graph it, then you push trace and type in 60 for x, it tells you the y, okay? So you can do it either way. You get multiple ways to do this. Anyways, you get about 10.4 feet. All right? And then if we go to number 3, let's finish number 3 in the notes because that was another one that used the equation we found. So it wants to know what the coldest temperature is, okay? So that's using our vertex, which we don't know. We haven't been given that vertex, but we can find it. All right, so again, you could type this in your calculator for y equals 0.05, parentheses x minus 6, parentheses x minus 21. You push graph, you could trace it, and that kind of thing, and you kind of get an approximation, okay? Or you could push calculate, and it can calculate the minimum, okay? And do that. But mathematically, let's do it this way. All right, we know our x, our axis of symmetry, has to be halfway between these 2 points, right? So I know my x value is going to be halfway between 21 and 6. So I'm going to take 21 minus 6, and I'm going to divide it by 2. All right, so I get, gosh, it keeps doing that. I get the x value is 13.5. So if I know the x value, I can plug it in for these x's, type that into my calculator, that whole equation into the calculator for those of the x's, and I get y. So 0.05 times parentheses 13.5 minus 6 times parentheses 13.5 minus 21. I actually get negative 45 over 16, and we'll just put that as negative 2.81. We'll just round it. Okay, that's approximation. All right, so there's my vertex point. So the temperature is the y value. So the coldest it gets is that bottom point, which is the y value of my vertex, okay? So the coldest temperature is a negative 2.81 degrees Celsius. Then it says, what is the average rate of change of the interval in which the temperature is decreasing? So I'm going to erase some of this on my picture. I got a lot going on. All right, remember, rate of change is slope, okay? So if it's decreasing from here until it gets to that vertex, and then it's increasing from there to there. Remember, decreasing is when the curve is going down, increasing is when it is going up. So if I do decreasing, I know that my interval is when x is between 0 and 13.5, because remember this point is 13.5 comma negative 2.81. So, and slope is rise over run, so it's the difference of the y's over the difference of the x's. So difference of the y's, if this is x1, y1, this will be x2, y2, okay? So I have a negative 2.81 minus 6.3 over 13.5 minus 0. All right, so on the top, get your answer and then divide it by 13.5, and I get that it's approximately, or is, negative 0.675. Well, actually, I plugged it in not rounding my y value. So rounding, it's still, my decimal came out exact if I left, the y value exact. But when we rounded the y value to negative 2.81, you actually get negative 0.674814. It keeps going. So it still rounds to negative 0.675. Okay? Now, if we do this when it's increasing, that's to the right side of my vertex. All right, so now I have x1, y1 being my vertex, and x2, y2 being the other intercept point. And I always work from left to right, in case you're wondering why I numbered them the way I did. So if I take y2 as 0 minus y1, so minus negative 2.81, over x2, which is 21, minus x1, which is 13.5. All right, and once I simplify all of that, I get 0.375. All right, so that is the average rate of change during those intervals. Then it wants us to compare the average rate of change. All right, now to do this, I actually want the absolute value of each. Okay, so my decreasing, the absolute value of negative 6.75. And then I have the absolute value of 0.375. And I want to determine which one's bigger. Well, absolute value means everything's positive. So if that 0.675 is positive, it is greater than the 0.375. Okay, because it's wanting to compare the rate of change. It doesn't matter if it's a negative rate of change or a positive rate of change. That's why I did the absolute value. So we want to determine, okay, so when it's decreasing, because that was where I got that negative 0.675, is when the rate of change is bigger, and it's decreasing between x being 0 and x being 13.5. And the x values are the hours after midnight. So I would say it has a greater rate of change. And you could say 13.5 hours after midnight, except Big Ideas is going to actually use the time. So it's going to be between midnight and then 13.5 hours later is 1:30 p.m. All right, and that's how you interpret it. All right, so now you can go to the practice and do number 27 and finish all the problems. Make sure your practice is totally done. Submit it on Big Ideas, take a screenshot, and submit it on Canvas.